Welcome to Emergence.
Hi everyone, I'm Ojong, and today I'm excited to introduce our paper titled SEAL Suite for Evaluating API Use of Large Language Models. This is joint work with Ashish and Aditya from Emergence AI. Large language models are impressive across various language tasks, but they struggle when tasks require real-time, specific information access. To tackle this, state-of-the-art models have tool calling capabilities. Moving beyond a fixed set of hard-coded tools, researchers are exploring how large language models interact with real-world APIs. This is challenging because APIs are naturally dynamic, diverse, and frequently updated. Evaluating systems for such tasks becomes complex, especially as existing benchmarks have major gaps. In our paper, we introduce SEAL, an end-to-end testbed that evaluates large language models' tool use capabilities with diverse real-world APIs. I want to note SEAL is not a new benchmark. Instead, it's a standardized, customizable environment built on existing benchmark. This features sanitized data, an agent system using the AutoGen framework, and a robust evaluation pipeline. Our main contributions include first, identifying the limitations of existing benchmark, such as lack of generalizability and limited multi-step reasoning coverage. Also, presenting SEAL, which incorporates an agent-based system to evaluate language models in retriever, planning, and execution. We also offer a full evaluation framework covering API retriever, API calls, and final responses for more structured comparison across diverse real-world scenarios. Before we dive into the main idea of the paper, let's first review a typical tool use system workflow, which is in Figure 1. It includes three main components: the user, the agent system, and the API server. For example, if a user asks, "What's the weather tomorrow in New York City?" the system must identify the relevant API, generate parameters, call the API, and then format the response. Many real-world scenarios involve multi-step tasks where outputs depends on previous steps. This requires the large language model to retrieve APIs accurately, call functions correctly, and then summarize responses effectively. Existing benchmarks focus on specific part of this workflow, and they often overlook multi-agent collaboration among components, between API retriever, main orchestrator, and potentially a planner or verifier. Next, let's discuss the challenges in current benchmarks more in detail. In this paper, we focus on 5 popular API use benchmarks. In Table 1, they include ToolBench, API Gen, AnyTool, MetaTool, and API Bench. They vary in API sources, number of queries, and need for multiple tools. However, we identified they are hard to generalize across different benchmarks. For example, Tool Retriever trained on ToolBench performs better on some rapid AI datasets, but much worse on MetaTool, which uses OpenAI plugins. Also, many benchmarks use overly simple, unlike real-world cases that require multi-step reasoning. Also, due to the dynamic and time-sensitive nature of API responses, these benchmarks only partially evaluate the pipeline, such as retrieving the correct API or checking if the final response makes sense. This brings us to SEAL. Since existing benchmarks have different strengths and weaknesses, we need a more comprehensive testbed. SEAL addresses this by offering a complete deterministic evaluation environment for API use. In section 4.2, we propose that API and tool calling tasks can be managed more effectively using an agent-based system. This is where multiple agents collaborate, some powered by large language models. In our AutoGen system architecture, these agents work together to handle user queries, allowing for flexible customization. so users can add specialized agents like a planner or verifier as needed. Additionally, Seal includes an API simulator. We follow stable toolbench methodology for this. The simulator replicates the real APIs using GPT-4 and cache all API responses to reduce stochastic variability. Also, Seal offers a comprehensive evaluation pipeline covering API retrieval, API call, and final response. For API retrieval, we evaluate whether the system identified the right tools. In terms of API calls, we evaluate whether the correct tools were called with accurate parameters. And lastly, in terms of final response, we evaluate whether the system fully addressed the query and the response was accurate. Now let's move on to the results. Our key metrics are recall at 10 for API retrieval, recall at n for API calls, API parameter accuracy, and pass rate for final responses. In order to assess whether task complexity scales with API pool size, we progressively increase the size of the API pool and the number of associated queries. Our two main takeaways from the table tree are the following. As the API pool expands, performance declines in both API retrieval and call accuracy. This demonstrates that the task becomes more challenging with more APIs. However, this decline is less evident in the pass rate. The second takeaway is that the standard deviation across different runs are substantial, especially in Toolbench. We think this is likely due to limited queries per API, causing variable distributions. We also identify 3 major error cases that could be useful to build future API use systems. The most common case is partially solved query due to incorrect API retrieval. For example, this query asks for technical specification of a film and search for news. However, this query is marked unsolved because the retrieval is failed to select the film API. Also, there are cases where language model cannot correctly extract relevant information from queries. And also, evaluation is inconsistent at times, as evaluation also relies on LLMs. This highlights the need for multifaceted metrics beyond the final output. Alright, in conclusion, Seal is a comprehensive testbed that addresses major gaps in large language model API use benchmarks. We have open sourced our code, so feel free to explore and try Seal yourself. Thanks for watching.